Hi, welcome to Mathematics with Tom. This is Tom, and today we're going to take a look at what's called the z-score. So that's our title for today. The title is the z-score. The z-score. Okay, so what I've drawn here is I've drawn a standard normal distribution. So we represented that with n, 0, 1, so it has a mean of 0, standard deviation of 1. Now, so far, we've been applying the empirical rule to find the areas under the curve. Well, today I want to change this problem. I want to change it entirely. So how am I going to do that? What I'm going to do is, let's try this. Suppose we're going to, well, let me label my curve first. So here's 0, and then we have 1, 2, 3. Minus 1, minus 2, minus 3. And suppose I asked you to find the area under the curve. Find area under curve between find area under the oh, how about this? I totally messed that up. Find the area of the shaded region under the curve. Okay, I'm going to pause. I'll be right back. And let's take a look at our shaded area. Well, I want to take a look at the shaded area. How about, let's just try this. How about if we find the shaded area, and we'll shade this in this orangish color. How about the area between 0 and half? Right there. What if I wanted to find that? Well, here's where it gets interesting, because now, if I was to use the empirical rule, I could say, and let's just make some notes in another color. If I was to use the empirical rule, what I might say is oh, well, if I'm between one standard deviation and minus a standard deviation, I could say, well, that's 68%. Well, then half of that would be, so then if I cut that in half, then I would be at this area. So this area here, you could say, well, that's half of the 68, so that's 0.34. And so far, my reasoning would be correct. But what I can't do is I can't say, oh, well, that's just half of 0.34. And the reason is that notice that what we have here is we have this curve. This region is curved. I mean, you could approximate it with a rectangle of sorts, I suppose, but it's not a rectangle. It's this odd shape. So at that point now, as soon as the point here is, as soon as the z-score is not a whole standard deviation, I'm going to just write a whole sigma, and by that I mean like the 0, plus or minus 1, plus or minus 2, or plus or minus 3, then the table of z-scores, must be used. Okay, so in your notes, the very last page is a table of z-scores. I'm going to kind of create one here on the screen, and we're going to approach this problem together. Now, so the question here that I'm looking at is, notice that I purposely said, well, what about this z-score is clearly between 0 and 1, so it's 0.5. Or you could think of it as 0.50. That doesn't change anything. So the last page, take a look at your table of z-scores, and I'm going to sketch one, and let's see how this works. So what you're going to do is you're going to look in your table of z-scores. I'm going to do it in a different color here. Let's use white. Okay, and I'm going to bring mine up to look at yours with you. Of course, I can't find them in there. Okay, now I have my table of z-scores, and what I would like you to do is you're going to look at where you find, you'll see the note a z in the top upper corner, and you'll see a column, and then you'll see a row. So underneath the z, you'll see like 0.0, 0.1, and you keep going down until you find 0.5. Now when you look at the row above, it says 0.00, 0.01, 0.02, and it goes all the way out to 0.09. Now, I want to look up my number, which is 0.50. So what I'm going to do is I'm going to go over from 0.50, so somewhere in this row, and then I want to go down in the columns of 0.00. Go down in the column. And where those two lines meet is my answer. And my answer is 0.6915. 0.6915. Well, right off the bat, we can tell that that's not the right answer. And here's why. If you look at your table of z-scores, notice that what it does is it doesn't give you exactly what we want. It gives you all of the area to the left and then up to our value of interest to 0.5. So it's giving us all of this region here. Okay, well, we don't want all of that region. What we don't want is we don't want the region that's on the left side of the mean. So we know that this part that I'm drawing with these light colored blue lines, we know that's 0.5000 as well. So that's a lot of 0.500s. But what we can have then is we can say then the area under our shaded region from 0 z to 0.5 is equal to the 0.6915 minus the 0.5000. So in other words, you could say that it's going to be 0.6 minus 5, 1915. So that would be the area of our orange shaded region. Okay, now let's try this problem again. And what I want to do is let's turn this one off, and now let's try another one. Let's try this. Let's try this. How about the probability? Oh, let me label it. I'm sorry, got ahead of myself. So my labels are 0, 1, 2, 3, -1, minus 2, minus 3. Okay, now let's just change the problem a little bit this time. Let's try the probability now. Probability that, so z, let's try one more like this, that z is less than 1.5. Okay, so what I'm going to do is, z is 1.5 is about right there, 1.5, and I want the probability of the area being less than that. So that's going to be all of this yellow region here. Okay, so let's look it up in our table again. So our table again, we look in our z-scores. And so it starts at 0.0 and then it's 0.1. You're going to go all the way down to where you find 1.5. And then this is just 1.50, so 0.00. So you're going to go over the 1.5 row, you're going to go down in the 0.00 column, and where those meet is going to be 0.9332. Okay, so that's this yellow region. This yellow region is 0.9332. Okay, now we're going to add another step, one that's really not much different in a way. What about the probability that z is less than negative 1.37? Less than negative 1.37. Okay, now this one's not so obvious, is it? So this is going to be, let's draw this. Let's draw it in orange. So negative 1.37, you don't have to be exact, but you know that it's, probably about here. So that's my negative 1.37. Well, what we want is this orange area. So the table always starts by giving you the area all the way out to negative infinity up to where you want to stop. So again, let's look it up in our table, our z table. So we're going to look up z. And this one's has a little bit more. Now you're going to want to look at the part of the z table that has the negatives. So it starts out at like negative 3.4, negative 3.3. And you want to go down until you find negative 1.3 in that row. And then in the columns, remember the column goes 0, 0, and then 0.01. And you're going to go all the way over to the column 0.07. And then, so you're going to go over on the negative 1.3 row. You're going to go down in the 0.07 column. And you should come up with, let's see, I'm coming up with 0.0853. Okay, so this is 0.0853. Now, I've got an idea. Let's try this. Let's try the probability. Let's do this in white. The probability. Now, what about if z is between those two values? So negative 1.37 less than z less than 1.5. Okay, let's try that. Well, in other words, let's use this green color. We've already kind of set the problem up. What it is I'm going to outline it here in this bluish, this light blue color, or this light green color. It's this region in the middle here that has negative 1.37 on the left side of a boundary, and 1.5 is the right side of the boundary. Well, notice this. We found the area for both of those. We found the area for 0.15, and that's the area from negative infinity up to 1.5. We also found the area for z is negative 1.37. And again, both of those both of those started all the way out here on the left at negative infinity, and then they went up to their respective boundaries. Well, in this time, what we can do is to find the area that has these vertical green stripes, is we can say, okay, if we found all of the yellow region for 0.15, well, all of the yellow region, that was 0.9332. And then what we want to subtract is the orange region, so we're going to subtract off the orange region. We don't want that. That's 0.0853. So we subtract those, and that would be the area under our curve. And so if you have a calculator, whatever that would be, I think it's like 9147, like that. Okay. We're going to try one more, and I think we can do it on this page. And we're going to do it in another color, though. We're going to do it in this nice pretty pink. And that is, what if I want the probability, yeah, I think we'll fit it right here. What if I want the probability that z is greater than 1.5? Okay, well, we've already found the numbers for 1.5. That was the 0.9332. That was the area to the left, but we don't want that. We want this pink region now. That's this. This is all the region above. Okay, well, think about it this way. If we take the pink region plus all of the yellow, that would be 1. So the pink area, so we'll call it the pink area, plus all of my yellow area from the first one when we calculated for z, well, if we added those together, we would get 1. So to get the pink area, so to get my pink area, what I can do is pink area is equal to the 1 minus the yellow area. And that's how we can find it. So the pink area then, the answer becomes 1 minus 0.9332, and that's going to be 0.0, oh goodness, it's going to be an 6. I think that's right. 990, I think that's it. 0.0668, and that is how we use the z-score to find the area under the curve for areas that don't correspond to perfect standard deviations. So the standard deviations of 1, -1, 2, -2, 3, -3. At that point, we get to use the table of z-scores. I hope that helps. Thanks for watching.